Again, my name is David Garrison. I manage the component and engine maintenance organizations within Delta's maintenance headquarters, if you will. I like the music, thank you. We are based in Atlanta. We go through a significant amount of work. What I want to talk to you real quick is a quick overview of who we are. I think we want to share with you our implementation and our results. We've gone through several phases. It's been a roughly 4-year journey for us, and I think it's important to focus on the word journey because we're clearly not done, and we're actually opening up more opportunities as we dig further into this. And of course that leads to sustainment, and I mentioned I would like to offer up some Q&A if possible. Real quickly, Delta Airlines, most of you folks know who we are. We are based in Atlanta. We were founded about the time the Hoover Dam was proposed. We do have 354 destinations across the globe, 65 countries, and growing. As you know, we've recently merged with Northwest Airlines. Certainly has grown our scope. 730 aircraft. We're proud. We operate every single one. Airbus, Boeing, we bring them all. Certainly introduces plenty of complexity for our business. 75,000 employees and growing. I mentioned technical operations. We are all based in Atlanta, home of Georgia Tech, I think it was mentioned earlier. We do have several stations or satellite stations throughout the country, but most of our work is done there. Our engine and component work is mostly based in Atlanta. In that facility, we have roughly 8,500 employees. It's a large facility. I encourage you, if you're an opportunity to come visit us. It is quite overwhelming. Again, a big business. One transition we have made in the last 3 years is trying to leverage our internal capabilities for revenue opportunities to give back to the airline. We have been doing this again for about 3 years. We are achieving roughly $500 million worth of revenue that we can again provide back to the corporate structure. Our goal obviously is to get to $1 billion in the next 5 years. I talked briefly of what our scope is. I'll get into detail around the engine piece of our business. I think one of the most important things I want to make sure you take away from this slide is there is plenty of complexity. Our engines account for about 80% of our revenue. We do have the merger, and we'll talk about some of the advantages that has given us. Component organization, I mentioned that earlier. We produce roughly 60,000 components on an annual basis in that organization. We have not done a TOC implementation in that organization. I'll talk about some opportunities that we have there. We also have a line operation. That is the operation that you see at the airport, covering 25 different maintenance facilities across the globe, and certainly transporting folks to cover down aircraft all over the globe. Airframe. Airframe is our overhaul facility for our aircraft. Sanjeev mentioned implementations in several different places. We are looking at a possible implementation in our airframe and overhaul facility. You can see that we've added Minneapolis and Detroit through the Northwest merger for opportunities of growth. I think it's important to get some perspective here. A lot of complexity in this division, a lot of variability associated with all the work that we do. I'll probably spend less time on this particular slide, or this particular theme here, but I think it's important that we talk about some of the softer sides of implementation that we have seen. As you folks know, bankruptcy was a big issue for domestic carriers over the last about 3 or 4 years ago. Northwest and Delta Airlines both transitioned and transformed themselves through bankruptcy. In that bankruptcy process, we spent a lot of time on transforming not only our leadership but our people. And I think it's important, again, to spend a little bit of time on this before we get into some of the implementation specifics. Things that we focused on was obviously transformational leadership. We needed to ensure that all of our leaders from every area, from every aspect, were absolutely committed to the team and the objectives of the airline. It was important that we all be aligned with what we were trying to accomplish. Passion was certainly a requirement. Bankruptcy is not a fun thing. If any of you have been there, I'm certainly sure you don't want to go back. And cultural change. We had gotten comfortable. We had absolutely convinced ourselves that there was no other way to do business. We have done everything, and what more could we possibly do? So we gained a sense of entitlement, and what we needed to transition to was what we call profound responsibility. Responsibility at every level. Again, responsibility for the success and execution of our engine shop, for producing engines on time, and actually getting aircraft off the gate. Focus on past failures is what we tend to dwell on. And let's look at the opportunity for pride and hope in the future. Again, and trying to instill this into the culture at the airline, and certainly setting clear expectations and shooting for the stars with some implementation and process change to be on top of that. And that takes me to the last piece here, which we'll talk about, is execution change. Execution change needed to happen. Service at any cost was absolutely our focus as an airline. Now let's look at the entire system and see what we can achieve by creating true value. Local optima rules. Every man for themselves, right? Every shop trying to do the best they can. Every manager trying to impress their boss and produce the best shop that they possibly could. Transitioning to this key to effectiveness is across the system. I've circled that with communication. We all know communication is an essential component of execution and successful leadership, and absolutely we can talk some more about that later. I mentioned journey as we started. 1995, we began the process of what we'll call continuous improvement teams. Very localized success stories. We celebrated the wins, we ignored the losses, and we continued to foster an environment where individuals and individual teams could create success. We introduced different tools, high performance workplace, Six Sigma. You've heard them all, you've seen them all. Some things are still in place, some things are not. We got small step changes, small changes, 2 to 3%, 5% through all this process. Grew a lot of frontline enthusiasm, involvement. There were some good things that grew from that. But as we went into TOC over the last 3 to 4 years, we stepped significantly. We took a 3 to 5 year improvement into 10, 15, and in a lot of cases 20, 25% improvement. And we'll talk a little bit about how we did that, but absolutely a key to our success. So as we get into the nuts and bolts of our TOC implementation, classic scenario. I mentioned the engine shop. We have 6, 7 products. Okay, within that product, we have 2 or 3 different types of configurations. For example, CFM56 is an engine on the 737 aircraft. We have the CFM56-3, which is on the classic application on the 300s. We have the CFM56-7, which is on the next generation 37s that Boeing have produced. We also overhaul the CFM56-5 for the Airbus application for customers. Delta does not operate it, but we overhaul it for our customers. Additional complexity within these 6 or 7 lines of engine work. So, traditional process, if I can get this to work here. Engine comes in, we work like crazy, we disassemble it. Got some wins there, right? Fastest disassembly you could possibly get. Then we take all those parts and what do? Shove them into the system. Quick, let's go. Get it done. The faster they go in, the faster they come out, right? That's what we did. Created 20,000 open shop orders with all the work that was being done in the shops. So all these parts come out, and Sanjeev mentioned this, right? We have an outside repair process. We do some work in-house. We do have a repair and support function that basically does what we call piece part repairs. Some capability forces us to go outside. Then some parts don't salvage. We can't salvage those. So we do scrap replacements. And of course, this is the internal process. Everything's great. Everybody's working hard. We don't know where our priorities are. We get to the end. Engine needs to be shipped. Engine needs to be built. So as soon as parts arrive, folks start building, right? Idle mechanics. They don't like to be idle. They do not like to be idle. They get a part, they get 2 parts, they can put them together, they'll do that. They finish that job, they get 2 other parts, they put them together, they'll do that. Okay? Local optima. Very successful at the local area. 4-year monthly average of production, 38 to 40 engines per month. This area is right here where I want you to focus. That's where we were before our implementation. You see these challenges, you probably face them all. I'm not going to go through them all. They're the classic scenarios. Okay? Then we go into what happens on the operation. Localized metrics, localized performance, no management of WIP, etc. 38 engines at the end of the day produced with that system. Flow implementation. I don't think I need to go into this in detail. Sanjeev at a high level mentioned our implementation program. We basically broke down the process, ensured that we satisfied the pipelining and the controls and the buffer, and we'll quickly go through this process. The induction process, very controlled. Today we look 30 days plus out by serial number, looking at every engine and the scope that needs to be introduced, and make sure that we can see exactly what needs to go into the shop and when. We look at how we disassemble, and we shoot for a D0 category or a D0 measure for that process or that critical chain process in that shop. Once the engine comes down, we meter the flow of those parts through our repair process. And in this case, in our first implementation, this white space was actually a dead time. We held parts. We took parts out of an engine, we put them in a locked cage. This is true. We put them in a locked cage. We still have that cage today. We made our mechanics route parts to be held. Okay? A lot of folks thought we were crazy. Then we released them on a scheduled release program. And you can see here A-15, assembly date minus 15 days, and inserted them into our repair process. In conjunction with that, we had parts that went outside. Those parts took longer to repair. So we called them exception parts, and we went ahead and released those into the outside repair process. So while that process is spinning, in 15 days it's spitting. My light's not working here. In 15 days it's spitting out parts. Now if we have hiccups, we have variability, parts fall out, mechanics do the wrong thing, we see something that scraps that we didn't anticipate, we utilize this buffer to ensure that we can recover. And Sanjeev mentioned that. That's the inventory that we purchase in cases to buffer that process. Okay? So this system operates on drum buffer rope. We choke it with a rope, we operate on a drum, and obviously we put buffers in here to deal with variability. Now the parts start coming out. We don't allow our mechanics to assemble an engine until we have 100% of all our parts. Okay? Then they go through Concerto and they use critical chain to manage all that. In some cases they have 4 or 5 engines that need to be built. So the Concerto tool allows us to ensure that we've got the right focus, we've minimized multitasking, and we're executing quickly on our assembly process. One of the biggest challenges in terms of cultural change was telling our mechanics not to build an engine until we had all the parts. We're still evolving into that process, and it's a challenge for our leadership team. So that is our implementation 3 years ago. I just walked through these real quickly. These are the words of what I just said. Critical chain implementation in our assembly and disassembly component of our engine shop. So that's when all the parts come in, we actually take the engine down and we build it up for test. Drum buffer rope in our repair shops. Okay? We mix all these parts together. We mix parts from the CFM, the CF34, the JT8D, the PW4000, the PW2000. All those systems are mixed into our repair and support program operating under drum buffer rope and moving at a 15-day cycle, if you will, at that time. And of course, exception management. You have to deal with the exceptions. You have to put buffer in the system to deal with the uncertainties. And we localize and we use inventory to do that. So what did we gain in this implementation several years ago? 23% increase in engine production in 1 year. We hit 586 engines. Our highest engine production that I've ever seen. Been in that shop almost 19 years. 50-plus engine per month consistently. You saw prior to implementation, we were anywhere from 38 to 40. 25% increase in piece part repair. That's that drum buffer rope process. That's throughput through that process. Turn time, 30% average reduction in turn time. Okay? Significant asset availability increase for the airline. Okay? 70% reduction in turn time of those piece parts going through that drum buffer rope system. Okay? And then we measure how well we do getting those parts back, and we look at 97%. We've gotten slightly better over time. We had a real busy summer this month. We've slipped a little bit, but again, continuing to evolve there. Piece part whip. Taking all that noise out of the system and reducing whip, you can see we took a lot of stuff out, down to 8,000 piece parts. Today, I think we're sitting around 7,000. Some cases we've been down to 5,500, low 6,000s. You don't lose the production. You gain by reducing that whip in the system. I mentioned revenue. I mentioned our opportunity to make money for Delta Airlines by doing work for other customers. You can see over $500 million in revenue for the entire business. engines increase their profitability and absolutely increase their revenue contribution for the airline. Well, guess what? That was two years ago. We could have stopped. We could have decided, just keep on, let's see how this goes. And certainly someone in my position, I have an engine and component organization. I love to implement, and it's great to walk away and go do something else, right? I think we've all been there. Go get this done, and let me know when you're finished, and let's go work on something else. The reality is that doesn't exist. The reality is with this system is it must continue to evolve. It must continue to be watched, and you have to set up the systems. It's a very ironic situation. It's simple solutions for complex problems, but they do not run on their own. They do not run on their own. There's too many variables that come into play. You're talking about change in leadership. You're talking about change in people. And what I want to talk about now is how do we sustain this process? After 2 years, we didn't walk away. We looked for more opportunities. What were those opportunities, and what were those improvements? I like the autopilot, a little aviation humor. So you should recognize this tube diagram. Same process on the inductions, okay, controlled. Our planning organization has done a tremendous job improving that process over the years. Again, good visibility 30 days out, so we can prepare and we can try to eliminate any variability on the induction process. Okay, the big difference you will see here, if you notice, there's no white space. There's no white space. So what we did is challenge the repair and support organization to say, 15 days was great. Let's shoot for 10. Let's take 5 days off your repair and support turn time. So now we're inducting parts on A-10. Okay, so we're moving them faster into the system. So now we've shrunk the entire system. Now, the throughput through our organization, the WIP management, continue to be critical. But you can see that's where a lot of value was created. And we'll talk about some of the things we did to do that. We didn't take away the buffers. We didn't take away the critical chain management on the assembly side. And certainly we have some buffer on the end still. Okay, so a significant reduction in the repair and support, and that is the key to our latest implementation that we took on. Now, because we shrunk this period, we had to buffer and continue to buffer our outside repair work. Our suppliers, when we went to them and said, you know what, you give us parts in 45 days, but we'd really like them in 15. You can imagine how that conversation goes. Not a whole lot of success. So we did have to make some investments, and we'll talk briefly about how we did that and some creative solutions that we came up with. So I talked briefly about this. We extended the critical chain implementation. Actually, I didn't hit the landing gear. This is one of the other implementations we did, and I think this deserves a lot of focus and recognition. 50% reduction in cycle time. 30-day turns on landing gear. Very proud of that. If anybody is in the landing gear business, you talk about dealing with landing gear, there is just as much variability. Chrome plating technology has not evolved. There's plenty of opportunities for us to improve, but we have a lot of variability there. Implementing the very similar systems that apply in that world. Improved drum buffer rope implementation, I talked briefly about this. This third bullet I want to make sure everybody gets. This is what we realized when we went into our latest phase of implementation. $60 million of monetized assets due to the turn times that we achieved on the Delta fleet. And just to quote some of those turn times, they may mean nothing to you. They may mean something to you. JT8D 219. We started this project at the very beginning. We were averaging anywhere from 45 to 55 days on a turn time. After our first phase of implementation, we probably got into the 30 to 35 days. Now we're averaging anywhere from 20 to 22 days. Okay? If you walk through that evolution of those steps, there's no doubt that you gain a lot of value for our airline. At one point, we operated with roughly 30 spare engines so that we could meet demand. We've almost halved that. And what did we do with those spare engines? We did two things. We took those spare engines and we inducted them into our shop. Of the parts that were critical to basically turn time, in other words, our outside suppliers or our internal turn time were not meeting our 10-day, we pulled those parts out of the engine and used those as buffers. So we didn't have to buy a lot of inventory. We had it. We had it in the assets that were not being turned through our shop because our shop turn was so fast. So we took those parts out, turbine blades, first stage turbine blade I think was a primary one on the 219, maybe a couple cases. And the rest of the engines that were available due to the turn time were used for what we call a part out program. So instead of buying a part when a part scraps, our shop took those engines, those additional assets, they disassembled them into piece parts. We put them on big pallets. We wrapped them with big saran wrap, inventoried them, checked their value, and we'd send them off to the other side of the building. When a part scrapped through this repair and support process, this 10-day cycle, instead of the traditional method, which would be what? Go look on the market and see what we can buy. The first step was moved from that to, let's go see what the inventory is in this big room. And when we went through that process, this big room full of parts on the 219 and the PW2000, which is on the 757 aircraft, we committed to Delta Airlines this year that we would give them back $60 million worth of savings. Okay, that's about 10% of my overall engine budget. To date, we're $1 million ahead of plan. We're right on task. Every quarter I have to go to our chief operating officer and tell him how successful we're being. Without this implementation, there's no way we could have done this. So it's a huge benefit. Now, here's the big challenge. You give the airline $60 million in 2010, what do they want in 2011? If anybody's got any good ideas, let me know. Still, it's that time of year. Some of the things we did that I think are worth mentioning to get to the 10-day turn, which was really the critical piece of getting this overall reduction in turn time, again, on the drum buffer rope application. Talk about leadership. This fourth bullet. A gentleman in this room, Gary Adams, took this on with his leaders, and it was well done. Eliminating outgoing queues, minimize the downtime of the parts, right? Roughly 6% of your actual touch time, of the actual turn time of the part, 6% of that is actual touch time. So let's minimize the amount of time these parts are sitting in queue. So we asked our mechanics to move parts. The traditional way is the mechanic finishes the job, puts them on a shelf, and they sit and wait for transportation. Transportation gets them, they go around the building, a couple times around, go get their break, put a part back on the next shop to work. We asked our mechanics to do that. There were several things that we gained from that. One is obviously we're moving our parts faster. The other piece is we actually had a real big problem with damaged parts. Many millions of dollars a year lost based on parts that are scrapped due to damage. All that damage was not due to transportation, but there certainly was a little extra care given when a mechanic is moving a part from one point to another. So we gained some intangible benefits with that. Still do that today. Another item that this organization led is productive management, total production management. What we also found as part of our constraint through that 10-day, from 15 to 10-day drum buffer rope was our machines. Our machines, we have a large machine shop. We do plasma spray, we do plating, we do a lot of CNC work on airfoils and different pieces of the engine and aircraft. A lot of downtime due to machines not working. No program implemented in terms of maintaining those machines. Now those machines are checked daily by the users, and then they get more extensive work on a monthly and quarterly basis. Seen a significant increase in productivity time, or if you will, or throughput, tied to the availability of those machines. So we've got the circle. We've all seen it, right? It's a little cliche, but at the same time it's reality. Enforce the rules. So we set up new expectations. We've made new improvements. We've continued to find ways to evolve this application in our shops. But I will tell you what, we love to break the rules. It is, and this is a critical point. It is so easy to break the rules because a lot of them are counterintuitive. And you have to enforce them. We have roughly 1,600 employees in our engine maintenance organization. We have engineers, we have mechanics, we have helpers, we have leaders. There are plenty of opportunities to break the rules. And I would tell you, if I thought we were perfect in this, I'd probably be fooling myself. We got a lot of work to do, and we got a lot of continuous leadership development and continuous focus on these rules. And you can see WIP reduction, WIP management is very essential to the success of this implementation. Priority rules are certainly important in the shop. We don't try to calculate, we don't try to manage every part and when it should be worked. We use FIFO. This is inside that repair and support, this drum buffer rope. We don't ask the mechanics to decide which part needs to be worked, it's FIFO. Now we do have an expedite process that allows us to get some flexibility when we have hiccups. It's a very rigorous expedite process. If you've been in a production environment, you have exceptions. You usually put an expedite process, and after about 12 months, maybe a year, this expedite process becomes a norm. And we used to have these flags. We'd expedite, we'd put a little flag. I think at one point we started out with 5 or 6 flags, and we ended up with maybe 50. Counterfeit flags to expedite parts. It was great. And you know, we got some really creative folks, no doubt. So now what do? We have a very controlled process. I think we have one person responsible for issuing flags. I don't think they're counterfeitable. I don't know if that's a word. And we actually release those and control those on a regular basis. Okay? And it's part of a key focus of the leadership of engine maintenance. We don't take it lightly. I talked about Concerto. We have probably different levels of implementation of Concerto, just to be completely transparent, so help you feel like, help you get a message that this is an evolution. We have leadership changes, we have priorities. We're going to continue to focus on implementation of Concerto in our repair shops. Again, as you transition in leadership, you are faced with a lot of challenges. I mentioned exception parts. You've absolutely got to manage your exception parts. I will tell you, I had a conversation with a gentleman in this room last week about, maybe we've gotten a little big on our exception parts. Okay, exception parts can be and also a tool for someone to say, hey, instead of doing this in-house, let me send it out, and then maybe out of sight, out of mind. And we got to make sure we keep ourselves focused on managing exception parts. And obviously, you got to measure. And this is very important, as you know, but I think the key point on this is making sure you establish your metrics correctly. So you don't drive local optima, you drive the organizations to the overall goal of the system, in this case, engine maintenance. You can see, kind of look at what our metrics are. I'm not going to go through them in detail, but you see the classic measurements, WIP, total part, throughput, things like this, and we look at our weekly results so that we make sure that the system is producing what it needs to produce. To enforce this process, we have the bulldogs. We do have some personalities that I like to leverage to make sure that we're keeping ourselves honest. We do have to make sure we stay focused on those results. We do have normal operations reviews to make sure that we are staying focused on those results. We bring the entire leadership in. They do actually meet on a daily basis. 10 a.m. I think is their latest meeting. They look at all the parts that are there. We look at our performance relative to A0. We look at any issues. We talk about safety. We talk about damaged parts. It's not led by me. It's led by the engine leadership team. It's a very good meeting. It goes anywhere from an hour to 4 or 5 hours, depending on where we are in terms of production. We've talked about this lately, refresher courses. Again, you get a lot of transition, a lot of movement, and the natural tendency is quite honestly to resort back to some of the behaviors that are destructive. Even after 4 years. Even after 4 years. And there's many reasons for that. The most obvious reason is because a lot of this stuff is so counterintuitive and you have transition of people that you have to continue to make sure that you settle yourself back into the simple solutions that are very effective. I've mentioned some of the challenges. I'm not sure this is a blessing or a curse, but the first bullet there, most of the original core team have been promoted. So we had a core team of about 3 or 4 folks that started this journey before I actually came into my job. And trust me, they had to educate me. I was starting to pick apart and do the things that we like to do when we get in our positions. Are you sure you're doing this right? Are you sure you need to do this? And there was many conversations about the do's and don'ts and things like that. But the core team that implemented this program have moved on to bigger and better things. And many of them have moved on to different areas within Delta Airlines for implementation programs, which is a great win. It's a great win for me personally. It's a great win for those individuals, and it's a great win for the organization. We can continue to foster this way of thinking across the business. Budget pressures are real. Budget pressures are real. It's absolutely a challenge that we deal with. Bankruptcy was 4 or 5 years ago, but it's not far from our mind. We still have a lot of challenges related to traditional financial measurements. Our corporation continues to measure us in the traditional ways. We'd love to change it. The reality is, it's going to be very difficult. So it's a constant balance in terms of how we do this. We've made some small structural changes in what we do, and what I've seen, just to put it simply, is as this process gains credibility, as people outside look to start to see these results, there begins to get a little momentum. There's a small bandwagon growing relative to what this system and what this process can do. Revenue pressure, certainly we've committed to the airline to give them money back for what we produce for our customers. That drives a lot of behavior for sure. Okay? And customers are wonderful, but customers like their stuff done their way, naturally. Delta Airlines does that to their suppliers. Okay? We have to deal with that variability. We have to give the customers what they want, but we have to introduce them into our system. I think it's important to note, though, all the metric performance improvements that I talked about at the end of the day for the system, the turn time and the asset reduction, are in the Delta turn times. Our customers, because of the variability, we're not meeting those outstanding turn times on our customer parts. Our ultimate goal is to convince our customers, if they become one of this process and allow us to utilize their engines and their parts like we do Delta, we can give them the same asset value. We can give them the same value back to that airline. And we talked about metrics. So before I get into questions, I think it's important to talk about future and infrastructure. There are several things that we are embarking on. I mentioned I have the component organization. I have a wheel and brake shop in Atlanta, Georgia. I don't think there's many out here left in the domestic United States. They are in the throes of their TOC implementation, a very production-oriented environment. We are also looking at critical chain management through our line maintenance and our planning and our material organizations. We're looking at opportunities to move our supply chain process from an allocation and forecasting system to a demand system. As you can imagine, we move a lot of parts across the globe on a regular basis. So the opportunities are boundless, and we look forward to continued implementations across the business.